Looking at this reaction, and we're asked to find the reducing agent. So a couple things we can do. We can start off by identifying what's happening to each species. Hydrogen shows up as an ion on the left side, the reactant side, and it shows up in a compound on the right-hand side. Odds are it hasn't changed. So we're going to assume that for the moment until we're shown something otherwise. I'm going to look here at my MnO4 minus 1 and my Mn plus 2 to see what's happening here. In this case, I'm going to use X to represent the charge of the manganese. I have 4 oxides, which are minus 2, and overall this ion is a minus 1. So that means X minus 8 equals minus 1. So X equals plus 7. It's going from plus 7 to plus 2. That is an example of it reducing. Now, our reducing agent is the species that oxidizes, so that's not the one we're going to be looking at. The next one we can kind of look at here is our carbon in the other compound. So if we start off with CH3CHO, that's basically, we have 2 carbons, so I'm going to use Y to represent that, plus 4 hydrogens, so 4 times plus 1, and an oxide, which is minus 2, and overall that species has a charge of 0. So that means 2y plus 4 minus 2 equals 0. 2y plus 2 equals 0. So 2y equals negative 2, y equals negative 1. Looking at the end of the problem, we've got CH3COOH. In this case, I've got 2 carbons, so I'm going to call that 2Z, plus there's 4 hydrogens, so 4 times plus 1, plus 2 times minus 2 for the oxygen, and overall that species has a charge of 0. So that's 2Z plus 4 minus 4 equals 0. Therefore, 2Z equals 0, so Z equals 0. As we can see here, we're going from minus 1 to 0. That's becoming more positive or less negative. Therefore, that is oxidizing, and that's what a reducing agent would be. So the specific species that's the reducing agent here is our CH3CHO.